Very excited to introduce Dr. Patrick Carrington, assistant professor at Carnegie Mellon University. He will talk about understanding everyday challenges to create accessible experiences. Patrick is an assistant professor in the Human-Computer Interaction Institute in the School of Computer Science at Carnegie Mellon University. We were there at approximately the same time at some point. He received his Ph.D. at the University of Maryland, Baltimore, and his research aims to deliver on the promise of accessible user experiences to support autonomy and improved quality of life. His work is motivated by a deep consideration of the challenges faced by people with disabilities, leading to the development of solutions that expand how people experience and interact with the world around them through technology. And with that, Patrick, the floor is yours if you're ready.
Thanks. Let me just get my slides up here. One sec. Sorry.
Sure.
You see the slides.
Looks good.
Just get my notes in the right place, and we get to go.
Yes, looks good.
Okay, cool, great. So thanks for that introduction. I'm happy to be here to share some of the work that we've been doing and to talk kind of at a high level about the work that we've done to kind of understand and focus on everyday challenges for accessibility, but with an eye towards how technology can best support people as we move through the world and as we have the goal of having accessible experiences, accessible user experiences. So to give, I've already had the introduction, so I can skip a lot of this, but I am a professor here at Carnegie Mellon University in the Human-Computer Interaction Institute, where I direct the Axel Lab. We already talked about, I got my Ph.D. at the University of Maryland, Baltimore County, and my focus during my Ph.D. was on interactions with mobile technologies and mobile experiences for people who use wheelchairs, with an emphasis on how these technologies integrate into better integrate into life while taking advantage of the unique opportunities that an accessible mobility device can offer. So that work translates into the work that we do here in my lab, where we aim to develop technology solutions that focus on and celebrate ability in its many forms. So the ability can take on capacity building, can take on extraordinary abilities, as well as what we might consider limited abilities. So the research that we conduct here aims to improve the quality of life and the quality of human lives through both technology interventions and social interventions. So if we think about a lot of the technology interventions that we see for the accessibility research that we've done, we aim to support access in two primary ways. Like, it goes beyond this, but if we wanted to summarize them, I think of bridging physical gaps. So think of environments or situations where someone's actions may be restricted due to a disability or due to some other constraint, as well as overcoming perceptual barriers. So encountering and encapsulating more sensory impairments or sensory related disabilities. And so in this case, we call them more information restricted environments. So the goal for that is to support access and then create experiences that enable the ability to essentially choose your own path as far as participating in different experiences, participating in different activities, whether they be new activities or ones that we encounter on an everyday basis. And so to introduce some of the kind of early ideas or ideas that are kind of foundational to the approaches that we take, we think about accessibility applications and the way that they influence the technology decisions that we make. So this is a photo from about 2 decades ago, essentially, that where John Braben actually employed or actually put on all of the technologies that they had developed at the Smith Kettlewell Institute to support non-visual navigation onto one person. And part of this illustrates how all of these different devices, even though they are well-intentioned, may not always be practical, right? So if a lot of these solutions actually conflict with each other, and then make the actual overall solution potentially less useful. Whereas intelligent applications like we think about with AI technologies, a lot of this case, we understand some of these things, or we can think of some of these applications, especially for people with disabilities, as early adopters. And it forces us to be very critical about the real performance of these technologies. And so when we think about people with disabilities as early adopters, this is often the case. So for instance, speech recognition technologies were used by people with disabilities before it was more widely adopted. The primary reason for that being that if you're unable to type, or if it's difficult for you to type, then speech recognition may have been useful to you, or more useful to you as an early adopter earlier in its development, before it became, before we saw the much higher recognition rates and much higher accuracies, even though it was an imperfect technology. And so this, the figure here references to Eric Horowitz's work in 1999, talking about the utility of actions and kind of laying this out as a model based on the goal of, based on whether the utility of the action could be derived, whether you should take action or not, if you have a system, whether or not it's correctly identified your goal. When you think about this in the context of disability, the utility component of this can change by default, because the cost of not using the system may be higher than you might think of for someone without a disability. Furthermore, when we think about AI systems, we often think about the errors and kind of bringing in that imperfection. This example from 2017 was an example from a captioning system, where you'd think that having a caption would be better than having no caption. But in this case, the image was posted on Hillary Clinton's campaign website for a sighted person. It shows a sighted person would be able to look at this image and see that it's Hillary Clinton walking onto a stage in front of a large crowd of people. Whereas the captioning system actually suggests that this is a man doing a trick on a skateboard at night. Now, while this description is clearly wrong, if the only way that you can interact with this image is through the descriptions that are provided either by a person or by a system, you may not be able to correct that error, and the error actually does send you in a completely different direction. Okay. Furthermore, as we think about technologies as they are emergent, this example from the blind driver challenge was an example around the same time, 2011, a little bit before that, when self-driving cars and autonomously driving vehicles started to become more interesting and more widespread. We saw this challenge come out where the goal, instead of kind of replacing the driver and having the car drive itself, this challenge was actually aimed at understanding and utilizing that technology in a way that was committed to the development of innovative non-visual interfaces that would empower blind people to be able to get the information necessary to actually drive the car themselves. So keeping humans in the loop. All right. So building on these ideas, the research that we do, I'm going to focus on how we've approached developing an understanding of user needs and opportunities in these different spaces before we actually get to the stage of developing any specific technology solutions. And so I think of this as understanding the opportunities for technology to support people's goals. And I'm going to talk about 4 different projects that kind of illustrate and understand how we work to gain an understanding of different aspects of daily life and interaction with the world, the different aspects of the world. We'll talk about physical access, information access, art access, as well as a little bit about transportation. So for the first project that I want to describe or share with you is actually focused on physical access for daily tasks. And this is work that we presented in 2021. And so as far as the high level goals of this project, again, a lot of this is aimed towards understanding opportunities. And in this case, we were looking at opportunities for multimodal inputs and to leverage multimodal interaction to support physical access for people who may have physical access challenges, people with motor impairments. And we conducted this work by doing semi-structured interviews with 12 participants with specifically with upper body motor impairments, to focus on understanding the relationship between different input types and input modalities, and to kind of map that or draw those relationships between task completion. And so what I mean by that is, so technology, if we think of technology in the broad sense, or AI-enabled intelligent technologies, we can understand that this has a role to play in many of our daily activities. And so on the screen, I have images representing activities of daily living that would be used to evaluate someone's ability to live independently. But these are all critical tasks that anyone would need to engage in or complete just for self-care and being kind of instrumental functioning in our society as we think of critical applications. So things like bathing, grooming, cooking, shopping, laundry, housework, these are things that everyone needs to do. For the purposes of completing these tasks, there are multiple pathways that someone with a motor impairment or someone using a wheelchair might take in order to complete the task. And the most straightforward one is the direct path, where the user themselves is using whatever physical motion they have available to them to complete as many of these tasks as possible. This is the direct path. This path involves two stages, where the first stage of it is the interpretation of their intention. So I intend to engage in one of these tasks. I would like to go shopping, I would like to cook, I would like to drive. And then the actual actuation of the physical process of completing the task or interacting with whatever devices or tools or objects in order to actually finish the task. Given the presence of certain impairments or certain difficulties, an alternate path for completing this may be involving the assistance of a personal care aide or another person to actually physically assist with the task, whether it be on the side of intention, where you communicate your intention to this person, or this person anticipates your intention and then helps to perform the physical actions that are required, or having that person actually complete the task for you. The third option, and probably the most relevant to this audience, is to do these tasks augmented by some form of technology, whether it be an assistive technology for interaction or assistive robotics for actuation. One of the challenges that we see here is that these paths actually are often exclusive paths, where there's not very much fluid motion between the direct path, the technology mediated path, and the path with a care assistant. They often replace one another. So one opportunity for us, in terms of findings from the study that we did, were these opportunities to augment but not completely replace the interaction with human personal care assistants, as well as specific applications related to the technology. So as far as individual input modalities, we explored 8 different input techniques and asked participants to describe kind of how they currently involve those input modalities and how they might envision interacting with them. And a lot of the choices that were made were very dependent on context, in addition to the things that we would typically think about, like usability. Can we complete the task? Is it possible? How easy is it? And how efficient it is to complete the task with particular technology assistance. Also, there was a deep consideration of the consequences of completing a task with a particular modality, such as I can complete the task on my own, but I might make a mess, or there may be additional setup or tear down or confidentiality concerns that influence my ability beyond the usability and efficiency of completing the task. One of the big takeaways as far as multimodal interaction preferences, or the combination of different types of inputs between touch, gesture, speech, biometrics, brain-computer interfaces, we kind of ran the gamut of possibilities, was that people wanted to combine the primary reasons for using any kind of multimodal approach instead of an individual or single modality was, one, for variability between different parts of the task. So to map different parts of a particular task to a different input modality, rather than having to stick with one throughout an entire task, or context dependent, where they wanted to actually vary, like sometimes I want to use touch for this, but in a different situation, I want to use my voice, or in a different situation still, I might use gestures to complete this task. Some of the big takeaways from this work, as far as kind of the user needs side of things, were some of those specific input preferences as they aligned with these different daily living tasks. So we have a collection of stories for all 18 of these tasks, as far as what people's choices might have been for interacting with particular modalities. So touch and voice, utilizing touch and voice for bathing, or combining voice and gesture input for doing housework while interacting with an assistive robot, or applying both gaze and biometric input for managing their finances. Another big takeaway for this was the conceptual framing of being able to break down the interaction pipeline into these component parts, and then being able to think about applying technology or intelligence to each of these different stages. So the interpretation stage, we can better understand the user and how they're communicating their intent. On the actuation side, we can interpret that input better, or interpret varied inputs better in order to actually complete the physical task while keeping the user in the loop in all of these situations. And so the need that emerged here was this need for intelligent adaptation during tasks or between tasks, such that the transitions between these different pathways can be more fluid. We see this as a big opportunity for intelligent systems to mediate, both in a collaborative sense as well as in an individualized sense. As we transition to a second project where we look more closely at a specific task, we look at cooking as a kind of a daily task, an everyday task, where in the non-visual space, or in the space for people with vision impairments, becomes more of an information access challenge for a very prominent self-care activity. And so with this in mind, our goal was to understand the overall experience of cooking for people with vision impairments, rather than kind of drilling in on specific visual challenges or functional opportunities. So we wanted to understand what approaches people were taking initially, what techniques were employed, what kind of key challenges and concerns or risks were encountered that led to people either not cooking or adopting different practices for cooking. And then what were there specific potential opportunities for assistive tech to support people with impairments to cook independently. And for this, we applied a different set of methods to gain a broader perspective. First, we used YouTube video analyses, where we watched over 122 YouTube videos focusing on capturing different cooking practices of people with vision impairments who cook for themselves. And then we followed those up with semi-structured interviews with 12 visually impaired people who have experience cooking for themselves or for others. And from this, you can imagine, we found numerous challenges with respect to gathering or utilizing visual information, from the use of specific tools. But some of the bigger challenges and opportunities that we saw were for status checking and maintaining status, or identifying the quality of different ingredients throughout the process. For instance, maintaining and managing what step in the cooking process you're on, or understanding whether a particular ingredient is cooked through, or is at the particular stage of doneness that it needs to be for a particular step. Right now, the approach involves a lot of use of the hands and touching a lot of hot surfaces, or potentially touching a lot of hot surfaces. So maintaining a safe environment while still being able to check and while still being able to utilize the tools that you have available to you also became very apparent. Furthermore, one of the strengths of kind of AI technologies, object recognition, and computers in general is the ability to be very precise and organized. And so we saw this as another opportunity that kind of emerged from this, where people were adopting various strategies to organize themselves, organize their tools, and then remember the status, remember the locations of different objects, and have very specific setups in order to achieve their goals, where technology may allow us a little bit more freedom and flexibility in how we approach these different avenues. And finally, in collaboration with others, a lot of the folks that we talked to preferred to cook on their own, not because they didn't enjoy the social experience, but because of the difficulty of being able to visually navigate the cooking environment, or the kitchen environment, with others, moving through space and communicating with others. Where technology technology has a potential to step in and kind of mediate some of these interactions, whether it be camera-based technologies or just kind of a global sensing approaches. And some of the other clear opportunities that came from this were zero-touch interactions with both devices and certain cooking equipment, especially for safety. In terms of devices, a lot of times you're touching food with your hands and you don't go and touch your devices, you get your devices and things all dirty, or you have to wash your hands a million times just to check a recipe or to go back to a recipe book. Again, I mentioned status tracking and safety monitoring. And then applying these techniques, or applying the powers of observation to introduce kind of active learning approaches, potentially to understand different behavior patterns in the kitchen, maybe walking pathways, stations, setting up areas that are where people are interacting, and learning from that to identify preferences for someone when they're cooking alone versus when they're cooking with someone else. And so some of the big takeaways from this work was an understanding of this active negotiation process between users, especially in a collaborative setting, but also in an individual setting. There's an active negotiation between the tools they're using, the environment that's set up, and the goals that they have for cooking for themselves. Technology in this space served more as was the opportunity for here was more as a memory aid and an additional ability to check on the status or quality of ingredients and the quality of the environment that they're in. It also highlighted the opportunity or the need to learn from people who teach individuals with vision impairments how to cook and how to navigate, and how what strategies may be broadly applied to individuals in a kitchen in a non-visual environment. So for this next project, this third project I want to mention, we take this idea of supporting individuals in their daily tasks. The first two projects I mentioned focused a lot on the functional aspects and kind of daily living and independence experiences. But with this project, we take a different view of bringing in aspects of creativity and looking at more social experiences. And this also leans more in the direction of more recreational activities and leisure activities, such as enjoying visual artwork. And so again, in this case, we're looking at vision impairments, but understanding how we can create unique experiences with art, especially with respect to creativity. So this was exploratory work that we did to understand more about the experience of artwork, the appreciation of artwork by people with vision impairments, because we know that this is something that visually impaired people do engage with, and that there are some access methods that are associated with these technologies and experiences. However, we know comparatively little about how well these solutions are adopted, especially in kind of a broad context. So again, we took a two-part approach where we interview people who are blind to learn their current engagement with visual art, including the access methods that they do adopt, the challenges they face with it, and their perceptions of the overall experience of interacting with these kinds of artwork or producing this kind of art. We also followed up our interview findings to think more broadly about how the findings that we got from the interviews would apply to other blind patrons thinking of things in like a museum or a gallery environment. So this, I want to give a little bit of background in terms of visual artwork. We're thinking of things like photography, drawings, and paintings. And these things allow us, in terms of our society, these allow us to express important ideas, evoke emotions, and to convey beliefs in a multitude of forms. And this has profoundly impacted and influenced human society since its inception. However, most artwork poses a barrier, most visual artwork especially poses a barrier for the over 2.2 billion people in the world who have a vision impairment, because the artwork there is typically inaccessible in a non-visual format. Furthermore, our experiences of art are far from uniform, meaning that art is often evocative and can have very different meanings or interpretations based on the individual person who is viewing that art, even if you're viewing that art, even if two people are viewing the same piece of artwork at the same time. So how can we support these kinds of interactions and understand and convey this in an accessible way? Although there are increased offerings in the gallery setting and museum settings for accessible tours, there's still a limited number of venues, and they're far from comparably enjoyable to what is offered to sighted visitors. In particular, blind people still face challenges with attending and experiencing art exhibits independently. As far as current access methods go, there has been existing research in this space to develop and deliver different access methods, including support for museum navigation using different tactile maps or audio navigation, with audio descriptions or pre-recorded descriptions of the artwork that exists within a space so that people can access using maybe headphones or a mobile device, We have production of tactile graphics that allow people to have a more tactile experience, to feel the artwork, especially in terms of sculpture or paintings. And combining the audio and tactile experiences into multimodal experiences, some of these in limited supply, but these do exist, and we are kind of advancing that. And there are even offerings of virtual art tours where a docent from the museum or someone or a tour guide will actually give a virtual tour or Zoom or some other web-based tour experience. But when we think about these findings and these experiences and these access methods, we find that there is imperfect support from these existing methods, especially when it comes to unique interactions. First of all, the pre-recorded descriptions often lack visual references, including spatial relationships between objects and colors. Smart technology-based solutions tend to lack contextual information and report very well on the objects that are present, but don't necessarily report that, okay, there's a sword and two people, but it is someone holding the sword. Where are they located? What are they doing? What are the actions that are present? As technology develops further, we're able to build on this, but we're still pretty far behind as far as the individual experiences. Remote tours are also a way to kind of counteract that, where the actual tour guide will describe in more detail what's happening, but these tours tend to be very one-sided and lack the closeness of interacting with the art yourself and the social interaction of understanding and talking to people around you or engaging with folks around you in a social way. And so this establishes, when we think about how to actually develop these experiences and build on the technologies, this establishes a need for shared vocabulary and grammar, so that every museum and every art enthusiast doesn't use the same language to communicate what's in that piece of art. And it often is also something that needs to be learned over time. As you experience more art, you have more engagement with artwork, you tend to pick up a particular language or vocabulary. And so we need to find a way to support that development. Furthermore, we need to also incorporate ways that you can experience art based on your own individualized memory or your individualized past experience, so you can experience the art in your own way. So I want to drill in on that a little bit more, where we think about considerations for art access methods. On the one hand, when we think about specific ways to incorporate the actual different methods, we need to have a better mapping or match between the modality choices and the comprehension goals of individual users and make these more adaptive. For example, tactile access is very well suited to subject and form, but not as well suited for understanding content. Whereas audio descriptions are very good for content, but don't necessarily convey subject, form, and context. So by combining these, you can address some of the limitations of one or the other. Furthermore, we need to develop ways to enhance objective interpretation. So one of our participants described this idea in terms of relationship with pre-recorded or past experience or social sharing of interpretations of art. So they said, I prefer to get a perception of the artwork from my own experiences, and I do not want to hear personal comments from people just like this or that painting is so pretty and meaningful. All I need is what colors they use, maybe the contours of the lines, what kinds of objects are present in the painting. And that will allow them to use their own imagination to experience the artwork in a unique way. And so this highlights the need for supporting unique experiences and the opportunity for technology to support such integration of past experiences with new observations. So the last project I want to describe is focused on mobility and transportation access. This emphasis on sharing of the sidewalk. So we're coming all the way back out from individualized experiences to thinking more about infrastructure and options. So in this case, we're aimed to understand opportunities and develop methods to incorporate stakeholder input to understand the impact on accessibility that new technologies offer, especially as more autonomous and more intelligent solutions are deployed out into the world, including both the transportation of people and goods. And so for this work, we've actually done observations of mobility and personal delivery devices when they're being in use. And when in various deployments, we've had community meetings with various stakeholders at different levels of this engagement. And we've interviewed people who have been impacted by past deployments of these technologies. As this is ongoing research, we do have more open questions than specific findings. But the goal of this work, again, is to understand the impact of micromobility options and these autonomous delivery robots on the accessibility of the sidewalk. A lot of the emphasis on autonomous vehicles has been on our impact on the roadways between cars that are self-driving and cars that are driven by people or by humans. We're still learning how these devices will change and change how we move through public space. But what we have already observed are adversarial interactions between community and several of these deployments, as they have been relatively imperfect interaction. They're imperfect deployments. In a lot of cases, the micromobility devices have caused obstructions on walks and led people to actually destroy or vandalize or remove these devices on their own in order to get them out of the way. And these delivery robots have posed experiences where they put individual users in unsafe positions because they're either blocking a pathway or taking up sidewalk space. So we're aiming to understand more about how we can create accessible experiences of using these autonomous vehicles and what that impact is on our pedestrian infrastructure. So to wrap up, because I know I'm pretty close to time, I'm going to summarize that in order to kind of gain this understanding, we employ multiple methods. We use interviews and discussion, critical evaluation of current solutions. We apply brainstorming activities and working directly with stakeholders, observations and design workshops, as well as prototyping and speculation of new solutions and possible solutions. And we do this to achieve a varied set of goals that go beyond just the function of the technology to capture maybe specific applications, to understand values, understand practices and processes, or the how question of how to actually perform these tasks and how to integrate technology, why these tasks are important to the individuals that are engaging with them. And we use that to drive what opportunities we actually take advantage of. Where we emphasize the everyday is because we often these everyday activities are overlooked in favor of productivity and other aspects that are outside the daily routine. But we incorporate these aspects that may not be as salient, but remain critical or crucial to maintaining identity and agency, where we can allow a person to have control over their representation and their interpretation of self. We also aim to maintain the value of interaction with people and view technology as an important component, which is able to augment this interaction in both positive and negative ways. And it has the potential to change the way that people experience and interpret the world. Finally, this shift from convenience to critical, in many cases, our understanding of the opportunity and utility of AI technologies is taken through the lens of convenience. But for many people, these functionalities could be critical enablers of the fundamental human experience. So we want to move from this modern convenience to getting to the fundamental human experience of the ability to choose how you experience the world and how the world actually experiences you. And so with that, I'll thank my collaborators and the people who made this work possible. And I'm happy to take any questions that you might have about this.
Thank you, Patrick, for the wonderful talk in understanding real-world needs and developing practical accessibility solutions. I will ask folks to put questions in the Q&A box. There should be a button for Q&A. And while people are typing their questions, I have a couple of questions. I have a lot actually, but maybe I'll ask one. Yeah, pretty exciting talk. So you mentioned designing across different tasks, which I found very interesting. So both you have kind of like an outside navigation, which is a very difficult problem, and maybe navigating in the kitchen. and even navigating through more abstract concepts like in the museum, like visual representations, and decoding that to someone who may not have visual perception. Do you find that there is some like elements of universal design considerations that arise out of these different tasks? Or generally, when you ask participants for the responses, do you find that each task kind of elicits its own requirements for anticipating each user's needs, or do you, or is more of there's some generalized framework that emerges out of these experiences?
That's a really good question. I think it is very context dependent, right? So the main thing that's missing from a lot of the individual technology solutions is that you can tailor a solution. A lot of the responses we get, my abilities are X. These are the things that I like to do. These are the things that I'm able to do. And the technology is usually agnostic to that. The technology often has a kind of universal approach. We're going to detect motion. We're going to detect electrical signals, and we can apply that kind of broadly. But understanding the individual person is often the need of developing a personalized model for how they interact with something. Mm-hmm. And it's an interpretation question. So going back to the interpretation versus actuation component. So there are elements of that where if I can understand your intent, then I can infer how to complete a task. How to complete the task could be augmented in different ways by how you are able, what parts of the task you're able to complete on your own versus what things you may need assistance with. Mm-hmm. As far as navigation between these things goes, a lot of it depends on kind of a global awareness. So if we think about the kind of AI and intelligence aspect, is that you need to have a global awareness of the setting, the space you're in, and what elements are in that space and how people could interact with them. Right. So there's a bunch of objects, but these objects need to have a deeper meaning. And they change based on where you are and based on who you are. So there's a need for communication. So you can have smart environments and you can have intelligent devices. They need to be able to communicate with each other. And that often is the barrier for having kind of a universal solution, is that there's often no connection between those things.
Great, thank you. Very interesting. There is a question here. There's another question from Emily. Thank you for the excellent talk. In the context of artwork and museums, what do you think about the role of augmenting or reinterpreting experiences that were originally designed for visual experience compared to creating new experiences that are tactile first or audio first?
This is a great question. So especially in terms of art, this is one that we engage with when we started to think about this space in terms of creativity and what is the representation, what is the intended experience, right? So when we think about artwork in museums, there is an emphasis, or there is a role that the artist plays, and the artist creates the artwork with a true experience in mind, right? So a painter creates the artwork, typically doesn't create it for a tactile experience unless that is one of their goals. They create it for a visual experience. So interpreting what that intended experience was from the artist is also, I think, a component of this, versus where you are creating an audio first or a tactile first experience. I think it also ends up being up to the artists themselves, right? Not necessarily putting the onus on the artist to create those experiences, but if you are creating that kind of experience, the tactile first or audio first experience becomes something that gets reinterpreted in the opposite direction, right? So we often have a visual representation of that tactile experience or of that audio experience, and it has to be converted. But I think there is a role to play in that. We need to understand the directionality and who's responsible for that. And I think part of that comes from understanding why people are motivated to interact with that artwork in the first place. Are they going Are they aiming to understand it from a particular lens or to gather a particular type of information, or to experience it the way that the artist intended? So in a museum environment, this is often mediated by the museum and how they've set up the exhibit to convey that information. So.
Great, thank you, Patrick. I think we have time for one additional question. And there is a question. Do you know if there are any existing practical tools for assisting cooking for individuals with visual impairments? Or I guess the question might mean something like a smartphone app or.
Yeah, so we're actually in the process of conducting a study that's looking more specifically at tools that people are using to get through the process and what kinds of intelligent tools exist. A lot of the tools that we've encountered so far as kind of a broadly available tools deal with object recognition or existing kind of assistive services like ERA or like the AIRA. Human assistance version of that, Be My Eyes, Seeing AI, Microsoft Seeing AI, utilizing those tools and utilizing more object recognition in order to achieve these goals. A lot of these are not specific to cooking, and so they have increasing applications, but are adapted in very individualized ways. We have encountered some more unique solutions through our study, but we haven't finished analyzing that data, so I won't be able to tell you exactly what